When solving linear inequalities in one variable, there are three main ways that we can represent that solution set. The first is graphing. The second is using a notation called interval notation. And the third is using a notation called set builder notation. Both interval notation and set builder notation are means of representing sets clearly and concisely using specific symbols. This video will outline how they are used to represent solution sets for inequalities. While graphing solution sets is a less common means of representing them, it's very helpful when first connecting an inequality to its representation as an interval. So we're going to look at 4 different inequalities, graph each, and then put them into interval notation and set builder notation. So for this first one, we have the inequality that x is greater than the number -4. Notice that this shows that x is strictly greater than -4, and we want to key in on the fact that this means -4 is not a number included in this set. So to draw that graph, we'll go to our number line, which I have marked out here with tick marks from -5, -4, -3, and so on up to 5. You'll also notice that my variable is x, and so this number line is labeled with an x. To graph this solution set, I'm going to go where -4 is on my number line, and I'm going to draw a rounded parenthesis that heads towards the positive side. Notice that x greater than -4 points to the right, and my number line will point to the right, representing all numbers strictly greater than -4. So I've drawn this rounded parenthesis opening to the positive numbers at -4, and then a line with an arrow pointing to the right. To then write this in interval notation, I'm going to use that same rounded parenthesis, draw a -4, and then put a comma infinity. And what this is showing is that I'm representing all numbers strictly greater than -4 going on indefinitely. One of the things that's helpful is to note that the rounded parenthesis I have on the graph of this inequality is identical to the rounded parenthesis I need in interval notation. The next type of notation I have is set builder notation, and this will involve using a curly bracket. I'll write an x, and then I'm going to draw a straight bar, which means such that, and after this I'm going to include x greater than -4. I'll end that again with a curly bracket, and so this is a shorthand notation of writing the set of x such that x is strictly greater than -4. The next inequality I'm going to look at is x strictly less than 3. This one is quite similar, however. We'll notice that it's less than, so it's going to be numbers smaller than 3. When I go to graph this inequality, I'm going to go to the number 3, and this time I'm going to have a parenthesis that opens towards the left side for numbers smaller than 3, and then I will draw a line and put an arrow on the end. What that gives me then is it's showing that I have all numbers going right up to 3 but not including 3, and all numbers smaller than that. That's why it's pointing to the left. It's helpful to see that the inequality symbol itself is essentially pointing to the left, and so I'm going to have all numbers from 3 to the left. When I go to write interval notation, 3 is going to appear on the right of my interval, with again that open parenthesis. Now on the left I want to show all numbers smaller, and so that goes on indefinitely. I'm going to put in the -infinity symbol there, and then between -infinity and 3 I'm going to put a comma. Note that I have an open parenthesis on -3. We'll talk about closed parentheses shortly, but with infinity and -infinity we'll never use a closed parenthesis to show that that's included, as we can't ever hit. And -infinity is not a number that we can hit, so that's excluded essentially. Now to put this in set builder notation, we're going to write the set of x such that x is less than 3, and to do that with mathematical symbols we're going to put a curly bracket, write x, and then the such that symbol we're going to use a straight bar, and then after that we'll put that inequality x less than 3, and we'll again end that with a curly bracket. The next inequality we have is x greater than or equal to 1. The key thing to note here is that this or equal to means that we will include the number 1. To show that when graphing this inequality, we'll put a square bracket on 1, and since it's greater than or equal to, we're going to go to the right. So I'm going to put a square bracket on 1. So I'm going to put a square bracket on 1 and then draw a line that points to the right. Notice that that square bracket also points to the right. I like to think of the difference between the square bracket and the rounded bracket as the square bracket essentially goes through this number 1, and that's a means of including it. When we go to write the interval, we're again going to use that square bracket. Note that when we look at our graph, we can see that 1 is the leftmost number. So I'm going to put a square bracket with a 1, and then it goes on indefinitely towards positive numbers. So I'm going to put comma infinity and a rounded bracket on that right side. To write this using set builder notation, I need to write the set of x such that x is greater than or equal to 1. And so using symbols, I'll write a curly bracket, an x, a bar for such that, then I'll put in my inequality x greater than or equal to 1, and end that again with a curly bracket. The last inequality we're going to look at is x less than or equal to -2. We'll note that this is less than, so it's going to be all numbers smaller than -2, and the or equal to means that we'll include -2. So we will again go to -2, and I'm going to start by drawing a line straight through it. And then, since I'm going to go to the left, that bracket is going to point towards the left, and then I'll draw a line with an arrow representing all numbers less than or equal to -2. When I go to write that in interval notation, I'll look at my graph and see that -2 is the rightmost number, and it's included. So I'm going to put a -2 with a square bracket on the right, and then I want something that represents all numbers less than or equal to that. So on the left, I'm going to put an open bracket with a negative infinity, and again, those are separated by a comma. When I go to write this in set builder notation, I need to write the set of x such that x is less than or equal to -2. So I'll write a curly bracket to start that set. I'll write in my x, I'll use a straight bar for such that, and then I'll input the inequality x less than or equal to -2, and finally I'll end that with a curly bracket.